welcome back. Here's the problem at hand. This is the bottom of our Bachmann passenger car. We're trying to replace the original 9-volt battery box with our own custom 3D printed one. You can see the two slots there, if you want to call them that take tabs on our 3D printed piece. We have a set of tabs that catch those just right. On this one you can see that will fit through there and then snap on. Let me demonstrate. Hopefully you can see what I'm doing here. We'll feed the connectors one at a time through the hole here. Maybe two at a time if we're lucky. One at a time. There's one. There's two. Excuse my hand. There's number 3. So, those will connect to the electronics in the battery box. You can see the tab there. Snap right in. Alright. So from there, we have a box that slides onto the lid, actually more like snaps on, and the design needs revision. So let's take a closer look at what we have now, what we're working towards. We have a 2000 milliamp hour lithium polymer battery. Excuse me, I'm just going to dump the things out here. So in here we have a charger circuit board, if I can get the wires out of the way, that has an exposure on the side for a USB micro connector to charge. So there you see, you can adjust it to be just right. Now the idea there is the battery will slide under there. Just fit and keep everything in the correct alignment. Now the other pieces here are on-off switch on the side here. You can see the little distribution board that has a connection to the battery and connection to the Arduino. So, excuse my hand. This is a Lowland, also have Amica, but this was the original ones I used. It's an ESP8266. It also fits in here and connects to the mounting holes you can see there. Lines up with the standoffs. So the problem I'm having right now is when I go to slide this cover on there, it's not the most reliable. So what we're going to do is we're going to make the box and everything snap in to the slots on the bottom of the passenger car, and then we'll have a lid that slides over the opening to cover that, like the original 9-volt battery compartment for the Bachmann passenger cars had. Hang on one second and I'll get you a view of those. This is the right one, yeah. So here's a view of the original. You can see the ears on either end, how that snapped in, and how the, if I could hold it, how the lid snaps, slides off of there, snaps in, opening, polarity, contacts for a 9-volt battery. So compared to what we have now, you can see slightly larger, a little bit longer, and a little bit wider. If you want to have the battery life, bigger battery, you can see that pretty much takes up what we have in there. Alright, welcome back. We're looking at the passenger car lighting project, and we have a few issues that we need to resolve. The way that works now, I don't know if you can see up here, the circuitry snaps onto the bottom. Well, not in that mess like that, but what the key idea here is, we replace the the existing 9-volt battery holder that snaps onto the bottom with something to contain a little bit more battery, a rechargeable battery, in this case a lithium polymer. Fits in the bottom like so, and the lid snaps in, and if you can see the snaps there. But anyway, I think you get the idea. The overall dimensions are slightly bigger, so if I put it on top of there, you can see it's just a bit longer, just a bit wider, and the box itself is just a bit deeper. It will fit, and if you don't like the extra size or having all the electronics, if you'd rather stick with the 2 incandescent bulbs, then there's always the option of a rechargeable 9-volt battery. They come in 650 milliamp hour option. The original alkaline 9-volt batteries are generally 90 milliamp hours. I don't know if it says on the side of this. In any case, you don't get very long use out of those before they're dead. If you accidentally leave one on overnight, the battery will be dead by morning. So the idea here is to not only give longer life, but to add different effects. In our case, it's replacing those incandescent lights with an LED strip. So here's an example of what they call a 50-50 LED. It has a red, a green, and a blue in each one of the chips. Each segment, if you can see between the connections there, has 3 LEDs, which have a red, green, and blue in each one of those, and then limiting resistors. The idea is you can cut it every three LEDs in each one of those segments to get the length that you need. So what I've done is I've fit 24 LEDs in here. Give me one moment and I'll grab an example. Alright, don't know if you can see that. These are the addressable 2812 LEDs. The difference being you can individually talk to each one of these LEDs versus the 50-50s. You talk to them all at once. They all get the same red value, they all get the same green value, they all get the same blue value. And if you want to cut it into different segments and individually address it, you'll need a red and a green and a blue driver for each one of those segments separate. At one point maybe I'll look at multiplexing that, but it's just so much easier to go with a 2812. And another bonus is 3 wires, runs off of 5 volts. So you have power, ground, and a signal line that allows you to address each one of those chips individually. What addresses those chips, what talks to it, is an Arduino. This is an ESP8266 based processor that has Wi-Fi built in. You can see the Wi-Fi antenna. Has a USB micro connection for uploading programs to it, and there's not much to it. You can tell it's fairly small. Now this is the smaller one. I also have another flavor. It's the exact same. It's just a little bigger. It's about 1/10 of an inch or 2.5 millimeters wider and about 3/10 longer. But the idea is this would connect to power, ground, and the one signal line that would address each one of the LEDs in that strip. So basically I need 3 connections, one for the data and 2 for the power. So that all being said, and I don't know if you can tell, this would actually fit in the 9-volt, the original 9-volt battery pack if I had a smaller battery. They do make smaller batteries. They make 850 milliamp hour batteries that are smaller form factor. But I had these on hand, and I've made quite a few of these. Now the problem that I've run into, what happens is the car's rolling along, hits a bump, and all of a sudden this entire box falls open, and now you have dragging equipment everywhere. The issue is this. I don't know if you can see it from there. This piece would snap in right here in place of where the battery box would snap in. And this box here is meant to snap over that. Well, it's not the most reliable connection, and the issue is when you mount the Arduino to the underside of it, now it's even more difficult to get that box to snap on there. You can't slide it on there. It's just, it's a mess. It needs redesign. Short story. So the new box, that was, let's call it Rev 0. This is Rev 1. Has a slide on top. So now what happens is I have a couple slots here. I have a couple of tabs that get pressed in, glued in place, and that's just an artifact of the 3D printing that it's difficult to get wide open areas like this supported without supports, and that becomes a mess to clean up. So when I run into that, I usually design it to where I can start out flat and build up from the build plate. Same with this. So when I print this, I print these side by side like that, along with a couple of these tabs next to it. So with those tabs glued in there, that'll snap right in where the battery box goes. Everything can be assembled into it. Standoffs to where you see the access for the programming connector. There's also another access port here for the charge unit. I don't know if you can see that. This is one of the old style boxes with the charger built in. There's a power switch that mounts in there, and then a little distribution board here to allow connection to the battery. So there's the battery. This battery plugs in there. This plugs into the distribution board through the switch, and then this plugs onto the power and ground connections for the Arduino. There's also a separate power and ground breakout for the LED strip. See that? There's the 3-wire connection right there, power, ground, and signal. This actually has a one of the bigger versions pre-canned on there. You can see the power connection, the battery connection, the battery, the charger, the power switch. All that's replaced by this new version here. Well, not this one because I found some issues. So let me show you what those are. Alright, before I move on to the issues with Rev 1, shall we say, one thing I didn't mention when I was espousing the benefits of the 2812 over the 5050, I said 3-wire. The 5050 takes 4 wires, red, green, blue, and not my version of color coding, but black for power. I usually use black for ground. But the addition of a driver circuit to drive each one of those red, green, and blue signals. So there's extra hardware, extra wiring, and on top of that, they run on 12 volts, not 5 volts. So you need some sort of a boost converter or 12 volt supply, something to boost that 5 volts into 12 volts. So now you have a battery charger booster that gives you 5 volts off of the 3.7 volt lithium battery. This guy here, make sure that it doesn't overcharge, doesn't pull too much current. But then you boost that again to 12 volts with this guy. Now this'll actually handle, it'll go up to 4 amps. But if you're feeding it 5 volts to boost it to 12, that's roughly 2.5 times. So 2.5 times 4 amps is 10 amps. You'd have to feed it on the 5 volt side. Well, these guys are rated at maybe an amp. So if you take 250 milliamps, a quarter of an amp, to run this guy, it leaves you with about 750 milliamps, 3/4 of an amp, to run the rest of your LEDs. Not good. So that, again, that's another reason why I decided to go with the 2812 addressable over the 5050. Don't get me wrong, the 5050s are great for, we had them under the train station roof. A platform would glow and fade and all those. You've probably seen the kits that you can get. I don't have one handy here. Maybe I'll bring it out later if I can find it. But it has a remote control, and it'll do jump and fade, and you can custom manually adjust your own colors. Just neat things like that. You know, it's meant as kind of an eye draw, an eye catcher. So again, addressable works better because now you can do marquee. You can do so much more, so many more effects. So that being said, let's get back to some of the issues with Rev 1 of the box. Well, you have this charger circuit, and you can probably see, I don't know how close I can get before it's a little blurry, but you've got this metal piece, and you can see there's a bit of a gap between it and the circuit board. So there's a bit of a, I don't know if you can see that. I'm trying to get just the right lighting. I put a ridge here to fit in that opening between the two. So that slides right to, oh, wait, what? It doesn't slide in because I put the rail for sliding the lid and latching the lid right in the way. So if I could put that in there, you'd see where, yeah, the charging port, yeah, not going to work. So that's one of the issues we got to address in Rev 2. Another Another issue, slide the top on. Now this actually, I was quite pleased with the ease. It's not too tight, not too loose. Maybe a little tight towards the end here, but snaps on almost, except, oh look, there's a bit of an overhang here. And I'm going to move my light back a little bit and see if that helps with some of the glare. Yeah, okay. So you can see there's a bit of an overhang. In fact, there's 40 thousandths of an inch or a millimeter of overhang, the thickness of that wall, that I didn't take into account when I said make it the same size as the box. So that's another change we're going to have to make. One more thing, and it's kind of hard to show you here with the whole clutter, and maybe I'll bring you back and show you on a different car here. But you can see the opening for the wires. It's about a 1/4 inch diameter. What's that? 5 millimeters roughly. Now that lets you get one of those wires through, but you can't even get one of these connectors through there. It's might as well enlarge that. Now the opening in the bottom of the passenger car isn't very big either, so you overcome that. You have it all apart, wire it, put it back together, and now you just have the 3 wires that come out that connect. So that's not as much of an issue as it is when you're on and off, snapping this on and off here and need to get the wires in and out easily, or just kind of rock it up so you can look at it, work on it, replace the board if it gets toasted, battery when it wears out, that kind of thing. So the other, like I said, I can't show you. Maybe you can see how there's the mounting screws here. Well, let me hold everything from falling over. I don't know if you can see that screw there. Well, if you look here, there's another one that I've taken out here, so this will sit flush, but that's not really recommended. So what I'm going to do is I'm going to add a bit of a, what do you want to call it, a knockout or a relief to clear that screw head in the Rev 2. So this was a good starting point. Gives me some things to think about, and let's take a break, and I'll come back and explain what we had to do. I've got to update some drawings and then warm up the 3D printer, print it. So once Rev 2 is designed and printed, we'll be back. To you it'll be a few minutes, to me it'll be a few hours, but see you in a bit. Alright, just kind of a fill in here. One thing I forgot to check, and before I committed myself to Rev 2, wanted to check putting the stuffings in the box and check the clearance on the lid, and it almost fits in there. Not quite. It has a bit of interference to where by the time you get down to this end, the battery is lifted up and it's interfering with these guys here that try and slide in there. I don't know if we can see in there enough. You can see the wire kind of there. But yeah, I think what we're going to do is, I can't get it off of there. I was so proud of that fit, and now we get to loosen that up a bit. Actually, I'm going to add probably another, I don't know, 20, 30 thousandths to that, just to give it enough clearance, and I'll probably take the sharp edges off of the profile there. I don't know if you can see that. I'll blunt those, And anytime you try and print something sharp like that, usually you end up with a little bit of ambiguity. Here, let me see. Maybe you can see that against the black, and see how it's got kind of the rough edge there. You can't really count on a very sharp edge. And that one kind of, you can see kind of a half moon, or not so much a half moon, but a crescent shape. Kind of a, you know, your thumbnail would fit something, you know what I'm saying. So we'll address those issues and we'll be back.